Assalamu alaikum warahmatullahi wabarakatuh. Today I'm planning to complete our PLC topics fully, inshallah. So we are left with two more subtopics on the PLC, Allen Bradley PLC, as I mentioned earlier, counter and math functions. And once we cover all these things, so we will have a basic to intermediate understanding about the how the PLC system works with regards to when we talk about PLC, how the PLC system works, we are referring to Allen Bradley PLC works. How does it work? So let's discuss. So counter is also somewhat similar to timer operation in terms of operation. Uh, So where do we use counter? Let's say, for example, you have a through beam sensor here, and there is a conveyor belt, and this conveyor belt, on the conveyor belt, you have lined up bottles, and as the bottle flows, you want to count how many bottles has passed through this sensor. So as the bottle passes through, the sensor will trigger the counter, and basically that will count the number of bottles passes through the sensor. So let's go further. So this is the block of the counter. As you can see, it is somewhat similar to uh, timer block. They have the address. Here in timer it starts with T, but here it starts with C, 5.0, 5.1, 5.2, so on and so forth. How many counters you want to use, you will refer to this memory address. And then exactly same like PLC, you have the preset value and the accumulator value. You do not have the time base here as like the timer block. So here, the accumulator value goes up by triggered as the timer, as the counter is triggered by the sensor. And as soon as the accumulator value reaches to the preset value, the counter done bit will become true. So this is for count up. This is counting up counter. So you have C51 to C520 to 50. There are three counters numbered. So you can have so many counters, so many, and you have preset value and accumulator value. Okay, so counter, you have three bits also: counter enable, counter overflow, counter done. Counter enable means when the rung is true, it will be enabled and your accumulator value will go up. And count done will be when the accumulator value is equal to the preset value. And if you do not somehow in the program, you do not have a mechanism to stop the counter after it finish counting until the preset value, then it may go, the accumulator value can go up, up, up all the time. And eventually it can, if you do not let it stop, it's a 16-bit memory state. So it will hold the maximum number of 16-bit, whatever is the maximum number to the power 16. And if we still keep on counting, there will be an overflow bit and it will be flagged if the accumulator value reaches to its maximum value. You can have a countdown timer as well. So similar to this, here the accumulator value will go down, and you will have an accumulator value and it will go down to uh, lower value. So if you have 100, you have a pre uh, pre-stored accumulator value 100, and then it can go down 99, 92, 93. So sorry, 100, 99, 98, 97, 96, 95, so on and so forth. So why do you need a down counter? Up counter is pretty straightforward. Like I have given the first slide, the example to count the number of bottles passes through the sensor. Countdown timer, one example can be given like a vending machine. In the vending machine, you store certain object that you want to sell. For example, canned Coke or canned Sprite. So let's say you have stored 100 cans of Cokes. So you want to know when you should top up these things, or you want to show an indicator light that once this is below a certain value. So you give, let's say, when it is below 10 number of cans, then you should turn on a light, indicator light, showing that the number of cans is depleted to a very risky level because people cannot buy any more cans. So you need to top up this can. So in this case, you can use a countdown timer. So this is the example, the explanations of count up, count down, enable bit, as well as overflow and underflow bit. So let me show you this is the counter addressing C50, so on and so forth, and dot the bit if you want to refer to done bit or TT bit or enable bit. So here, this is the important thing. So this is the three stack memory as similar to what we have seen in the timer. So accumulator value, preset value, and you have count up, count down. So this count up will be enabled if you are using it count up timer. If count down timer is enabled, if you are using it as a countdown, it will be enabled. And done bit will become true once the accumulator value will become preset value. And overflow will be if your accumulator value overflows, then it will become the whole 16-bit is full with 11111. Then it will become next, if you still count up, then this will become 1. In the case of countdown, it can be underflow, meaning to say it will go lowest value of the 16-bit if it is a signed number. So this is how the count up and countdown timer are addressed in the three stack memory system. Three stack memory system. Three stack memory system. Okay, let's move forward. So enable, these are the bit accessible memory as I have shown earlier as well. So you can either say C50/15 or C50/CU count up, enable, CD countdown, DN, and so on and so forth. Usually we follow this syntax instead of this, so it is easily understandable. Okay, so this is an example. Let's say you have this sensor that uses to count up. So you are counting 10 batches of bottles that passes through the sensor, the through beam sensor. So once the sensor is activated, this 0 will go to 1. And then once this second bottle passes through, it will be 2, so on and so forth. Once you have this accumulated value equal to the preset value, you want that light to be turned on. So then the done bit will be true, and you want the light to be turned on. And during counting, when the done bit is not equals to true condition because accumulator is less than preset value, so you are using normally closed condition. So you want your light to be turned on as well. This is a yellow light, maybe meaning to say it is the batch is still not finished counting. It is continuously counting at the moment. And as I have mentioned, the accumulator value will not reset back to 0 automatically. You have to use a separate reset button to reset this counter. It will cause the accumulator value to reset back to 0 for next batch, for counting the next batch. Now, if for this type of programming, this style of program, you will not have any checking mechanism that after 10 you don't want, even if there is a bottle passes through the sensor, you don't want your accumulator value to go up. In this style, you cannot do that. It will go up automatically. So there is no mechanism to stop counting after the accumulator value reaches the preset value. What you can do in the second style, you can use in series the counter done bit normally closed condition. So what will happen is basically once the accumulator value reaches the preset value, next then the done bit will become true. So means the normally closed will become open. So meaning to say later, even if you bring a new bottle because the accumulator is already reaching the preset value, it will not cause the accumulator to go up further up unless you reset this system, unless you reset it. So this is the way you can stop counting after the accumulator value reaches the preset value. So this is one way of programming. Now you can use an up down counter in the same program together. And one example of such thing is that uh, basically you want to count up, 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 and then suddenly you want to count down also. And then, so the typical example of such counter use in any system is that parking lot system. Let's say, for example, if you have a mall and you have a car going in, we'll count the car, how many. So you want to see how many empty parking lots available. So once the car, let's say you have 100 parking lots. So once the car go in through the boom gate, it will count up. So you will have, so your the assumption is you have one car park already occupied, and then you will have now 99 car park available. Now once you have, let's say, 10 car goes in, so you will have 10 occupied, so you can show that the remaining car park slots is 90. Now in the meantime, maybe one car leaves the premises, so it goes to the exit boom gate, so there will be a sensor it will detect, and that will cause the countdown option to be activated. So mean to say, from your 90 it will now go to uh, 91 available slot, because one car has left the premises. So this is the case. So one next slide. So this is the car plug slot. Okay, let me explain this thing. So basically, the entry gate detects the count up. Very important to note is that in both count up and count down, you have to have the same counter address, exactly same counter address, because you are referring to the same memory, but you are using two sensors to detect it as a two different way. So entry sensor is detecting it as a count up counter. Exit sensor is detecting the same counter as countdown. So you have a dynamic accumulator value will be more like a dynamic value. That means if the car goes in, it will go up. If the car leaves the premise, it will go down. So it will always refer to this preset value. So as soon as the done bit is equals to the preset value, sorry, accumulator value is equals to the preset value, meaning to say the 308, so the done bit will become true, and hence you will have this light to be turned on, meaning to say the lot is full, parking lot is full. So this is a typical example of a counter in PLC, using PLC. Okay, so that is all for the counter. Now we will move into math block. So the math block, similar to any other programming language, in PLC programming also you have different math functions and comparison. We will not discuss the program flow for this class. We will only discuss the math function and comparison block. So this is the math function and comparison. So math functions, like you can have addition, subtraction, multiplication, division, double division, all these things, clear, square, so on and so forth. So we will discuss some of them and how do they work. Let's say, for example, also data types. You have basically Boolean data, 0 and 1. You can have signed integer, which is 8-bit, minus 128 to plus 127. You have integer, not signed integer, not sign, sorry, integer. This is single integer. This is integer, which is minus 327682 plus 32767. Is also signed, and double integer is a much higher number you can store, and you have real number as well. Okay, now, so this is an addition block. So once you press this button, maybe it's an input, press this button, it will do an addition. So in addition, what you have here is basically you have a source A and source B, and you have a destination. So what it will do, it will add source A to source B, and it will store this in a destination. So what source A is a memory address, which is integer memory address n7.4, and you have a value here 100. Maybe you have stored it earlier or something, and you add it to the source B. What is the source B? It is pointing to the memory C counter 5.1 accumulator value. Whatever is the accumulator value, it will add it to this 100, and then it will store it to a destination, which is T43 timer 4.3 preset value. Why I'm doing it? This is maybe a part of a bigger program. That's why we're doing. I'm just explaining how this addition is working. Let's say you want to do subtraction, a simple conversion of Celsius to Fahrenheit. So this is the formula. So you will do addition, subtraction, division, and multiplication. So what you do first the subtraction, as you can see, 7.1 to 7.3, and store it 7.3, and then use this 7.3 to do the multiplication, and then finally you do the division. So you do the multiplication with 5, and then you do the division by 9. So this is your final result with the pressing of the same button. Okay. Let's say if you do not have any button, you just put just a straight line. What it means is that as soon as the power is on, it will do all this calculation. No input logic is necessary. Okay. So now there's an example. Design a ladder program with an arithmetic block that sets the upper and lower limits of a laboratory temperature chamber to plus minus 1/2% of a manually set temperature. So you want to do a temperature control. So you have to give a range that based on this, you will turn on and off the air conditioning or the heater. So the set temperature may be 100 degree or something 25 degree, depending on what is your requirement, and then you want to make it a higher range, 25 degrees, 1/2%, 0.5% of 25 degree, and 0.5% of 25 degree as a lower, plus minus. So what we do here is basically, so this is 300 degree Kelvin. We want to set it, which is 227 degrees centigrade. This is your actual set temperature. So you multiply with the 0.5%, which is 0.005, and this is 1.5 degree. This is the upper limit. So you set it to be upper limit, which is lower limit, 300 minus 1.5, lower limit, and 300 plus 1.5, which is the upper limit. So as simple as this. Remember the these blocks, which is the addition block or subtraction block or multiplication block, arithmetic block in general, should be on the right hand side as an output of your PLC. It should not be on the left hand side. It is on the right hand side of the PLC ladder program. So you can have also some move command, move, negate, move with mask. So I will show you how this move and negate command works. Move is basically simple. You want to move this memory, whatever is in the memory, to a destination address. N70 is moved to N76. Sometimes it is important to use. We will show you with some example. And you can have negate example, meaning to say whatever is in the source will be moved to the destination in 7.5, but in a negative term. I mean, if it is plus 8, it will be negative, minus 8, so on and so forth. Okay. Now, okay, these three addition, what does it mean? These three addition, the first one means even once you power on the PLC, it will do the addition. It will not wait for any instruction. And this second one means if you power on and if you press this button, as soon as this rung is true, it will keep on adding. It will keep on do this addition. And this case, we are using something called one-shot register. This one-shot register makes sure that only when this goes from false to true, only during the transition time, it will do the addition. It will not keep on doing the addition as soon as this rung is true. It will only do the addition once it is false to true. Okay. Now, this one, an interesting addition which you will need. This is something like a counter, but using an addition block. When you use an input sensor with an OSR, and you make your destination same as the source, and you keep on adding this value 1, let's say you 1, and the n70 is basically x equals to x plus a. So what it means is that I'm keep on incrementing by 1. Let's say n71 is 1. So I'm whatever initially it will be 0. So 0 plus 1 will be stored in 0. So it will become 1. Then 1 plus 1 will be 2. 2 plus 1 will be 3. So on and so forth. But make sure if you want to do that, you always have to use an one-shot register. Okay, let me pause here for a while, then we will again continue. Okay, so this is how we should be using a sensor for cumulative addition. You can do it for cumulative subtraction also. I will show you with an example. Okay, let's move on. So this is how you can do the cumulative addition, and you can also do cumulative subtraction, which we will show you in next slides as well. Okay, now here it says a limit switch operates a counter which counts rubber balls coming off a conveyor for loading into a shipping carton. Four different sizes of balls use same conveyor and the same size of carton. The carton can hold 96 balls of type A, 48 balls of type B, 24 balls of type C, and 12 balls of type D. A pilot line is eliminated when the carton is full. Select the necessary input fields device and design a ladder logic program to satisfy this automation time. So what we have to do, we have to first check a switch to select which counter to be used, because different balls will accumulate different number of different sizes of balls will be uh, used with different numbers in a particular size of box. So let's see how it can be achieved. So here what we do is that we use a limit switch that counts the number of balls. Okay, now what should be the preset value? The preset value can be different because different number of different types of ball will have different size, so the preset value will also change. So let's say if I want to use a 96 ball size or 48 ball or 24 ball or 12 ball, so you can see I can select the switches. If I use different type of switch, I have a selector switch. If I use 1, 2, that means I'm expecting it will be type A ball, which I can use 96 of them into a single box. And it will go to the preset value. So I move this 96 into the preset C51, preset value will be 96. But but at a time, only one type of ball will come through the conveyor belt. If I choose 48 type B, so then preset value will be 48. If I choose type C, preset value will be 24. If I choose type D, preset value will be 12. So this is the move command in action. So once this limit switch uh, causes to accumulator value to go up, as soon as accumulator value becomes equal to the preset value, depending on which type of ball we are expecting, then that your done bit will be true and your box full light will be eliminated, and you can replace that box with a new box. So next we go for the next slide. Let's see. That's all. Okay, now we go to some programming example. So we open the program here. Okay, let's open. Okay, we have discuss traffic light, pump on delay, parking. Okay, parking lot. So this is the parking lot example. There are two types of parking lot, using counter and using add subtraction. So let me show you this thing. Okay, now here we have to go and download and then click OK. I have to choose IO simulator. Okay. And then go to run. Okay. Uh, okay. All done. Okay. So now what we have here is we are using I10 as an entry gate sensor, I11 as an exit gate sensor. And we are using counter up and counter down, same memory address as I have mentioned, to show this is a 20 car slots available, car parking slots available. So now what we are doing here is we are just checking how many car slots are available. So let's say if, so what we do, as soon as the power is on, it will do some move action that how many, the counter accumulator value will be transferred to N71, some memory location, integer memory location. And then I'm using the comparison block, which I have not shown in the slides, but it just to show it here. You can have comparison like less than equals to limit test. You can have greater than, all these things you can have. So this one first, if what we do here is less than or equal to, so it means we can read it like this: if source A is less than source B, then do something. So this will be, your math block will be always on the right side and your comparison block should be always on the left side. So what it is doing is that if n7.1 is less than uh, b, less than a is less than b, then turn on green light. So now the b is, let's say, 5. So this is means that if it is less than 5, your accumulator value means you are fully open. So you are basically uh, turning on less than 5 car, so you are showing green. So if it is around already limit between 5 to 16, so you're showing yellow, that you have a rush in the, you don't have enough parking space, you have rush in the park. And if it is more than 16 already occupied, then N71 is basically accumulator value, which is means how many are occupied. So then you show red. So it means that you have almost no car parking available. So let me show you. So let's say I am pressing this. So this sensor, so entry gate is activated. So we have increased by 1. You can see accumulator value has increased by 1. Now if you press again, 2, 3, 4. Now we hit 5. So once it is 5, so it goes to the yellow light. The yellow light is turned on. Now again exit. Let's say we, one car exited the parking lot, so it becomes 4. Again this green light is activated. Now again you activate this, so exit, another car goes in. You further, another car goes in, another car goes in, another car goes in, another, and you keep on adding car. And then if it, as soon as it hits the 16, sorry, greater than 16, so it has to be greater than 16 immediately. It means a 17 car already occupied, so it is red. Now only 3 more available. So that's the thing, how you do the car park uh, programming. So you can now, if you car exited again, it goes yellow. So you can see how the system works. Now this same system can be represented using, same thing can be done using addition block as well. Here, if you do addition block, only thing I have done is basically replacing with uh, and addition and subtraction. So I'm adding 1 and subtracting 1 and storing to N72, same N72. Destinations are same. And I'm using one shot register. If you do not use one shot register, then you should not do cumulative addition, because it will not only do the transition, as long as the sensor is true, it will keep on adding. So you will get some false reading as well. So if you do this, it will do the same thing. Now let's see. So now it is less than 4. Let's say if you go one more, it is 5. So you go to yellow. and then you one car exited, it goes to green again. And as you can see here, if you go down, it will be red when it hits more than 16. So let's show you 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. You can see it is keep on changing, right? 16, 8, 16, 17. Okay, now it is red. So again, if you use exit, it will go back to yellow. And you go less than 5, it will go to green. So this is how you can do it. So as I have shown you, you can use the same counter up or counter down, or you can use addition subtraction for the same purpose. But if you use addition subtraction, you must have to use one shot register. So if you want to use one shot register, another thing you have to remember, uh, that you have to use two B311 and B312 internal memory as one shot register. And one shot register is located here. Bit under bit, you can see OSR, and you give the address for two different run. You have to use two different one shot registers. I think that is all for my PLC lectures. Hope you have enjoyed. I will upload these videos in YouTube as well as in Moodle. Thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.